Hello friends, welcome to my YouTube channel, and today we'll be discussing about overall view of petroleum refining operations, where we'll be discussing about what type of operations we are following to get a final products from a single feed, that is a crude oil. It is also called the raw material, also called a feedstock, and here we'll be using the crude oil as a feedstock. So basically, in petroleum refining. And today, I'm not gonna show any written content. I'm just gonna explain about the operations and the process. So if you want to note, you can note my words, what I am saying. So as we know that a petroleum refinery where we process a crude oil and it is a mixture of carbon, hydrogen, and in traces amount there is a sulfur content, nitrogen, oxygen, and metals. So basically we are saying that today we are discussing about like the feedstock, which is a crude oil, that is a mixture of carbon. The main content of crude oil is carbon and hydrogen, and there is also some traces of a small amount of sulfur, nitrogen, oxygen, and some other metals. So this parameter helps in deciding refining configuration and also how the crude oil is. So depending on these parameters, we'll decide how to design the petroleum refining equipments or operations. And due to these parameters, we also come to know what is the quality of crude oil. So crude oil is divided into three types. The first one is heavy crude oil, which has density of more than 22 to 20 degree API. API is American Petroleum Institute of Degree Measurement. So it is a standard set by American Petroleum Institute to measure the density. So that is why it is called degree API. Where in heavy crude oil there is a high sulfur crude, also low sulfur crude. When there is a high sulfur crude, that is the weight percentage of 0.5, and when it is less than 0.5 weight percentage of sulfur, that is called low sulfur crude. And also there is a medium crude oil and low crude oil. Means its density, that when the density is more it is heavy, and when less density than the heavy crude oil, that is a medium crude oil. And also lesser than that is called a low crude oil. So basically, depending on the density, these crude oils are divided into different types. Now, suppose we are now I'll be taking an example of processing a high sulfur crude oil in today's explanation. So suppose we are processing a high sulfur crude oil and low sulfur crude oil in one refinery. We are processing two types of crude oil in refinery. So depending, there is a number of crude oil distillation. So like we can say in a refinery, we use a different distillation units, crude distillation unit, depending on the parameter of the crude oil. So we are taking two types of crude oil, that is high sulfur crude oil and low sulfur crude oil. So we there can be one unit for a high sulfur and another one is for low sulfur. So basically, we're talking about a two distillation crude distillation unit. One is for high sulfur crude oil, another is a low sulfur crude oil. Now these crude oils are called feed. I already said that these crude oils are the raw material are said to be feed or the feedstock, and that are pumped towards the heat exchanger. These feedstocks are pumped to the heat exchanger. You can see there is a crude heat exchangers, and are heated up to 120 degree to 130 degree Celsius. So in heat exchanger, these crude oils are heated up to 120 degree to 130 degree Celsius, and it is moved to desalter. You can see This from the heat exchanger, it is pumped towards the desalter unit. This desalter, where the salt contents are removed, that is mostly calcium, magnesium, and so in this when these crude oils are pumped with the desalter, it helps to remove the salt content from the crude oil. And if these salts are left with the crude oil, then in the refinery plants, overhead will be corroded. Like the other uh, equipments or the units will be corroded, because when there will be salt, there is a high corrosion with it. And this desalter even remove, so this desalter even remove some metals, like we talked about, some metals are present in the hydrogen and some a small amount of. So if this desalter helps to remove some amount of metals as well, and if these metals are left out, then the catalytic process are done. The catalytic process are done to remove those metals. When after the desalter, this crude oil is again heated with the help of heat exchanger. You can see this after when the crude oil is from here, the sour water or the salt content water is removed from the desalter, which helps in protection and the corrosion of the equipment. Now this crude oil is again pumped and heated in the heat with the help of heat exchanger with a temperature of 180 degrees Celsius to 200 degrees Celsius. So you can see in the first heat exchanger, we heated the crude oil up to 120 degree to 130 degrees Celsius. So in the second, we are heating the crude oil into 180 degree to 200 degrees Celsius. Now coming up to this process, the lighter portion of the crude oil like fuel gas, LPG or some naphtha are vaporized up to this temperature. So coming to this state, after hitting a 200 degrees, 180 to 200 degrees Celsius, some amount of light crude oil, the light portion of the crude oil, like fuel gas, LPG, and some naphtha are vaporized. So we can extract those materials from the top of this pre-flash drum or the reflux drum, right? Okay. So the crude oil is taken to pre-fractor, this pre-fractor or pre-flash drum fractionator, which means the vaporized products are taken out from the pre-fractionator column. I said this the lighter portion of the crude oil, the fuel gas, LPG, and some other naphtha, those are taken from the pre-fractionator unit or the column. And the bottom material of the fractionator, unit is further heated and taken to the furnace. So you can see it's further heated with the help of furnace, and it is heated up to 350 degrees Celsius to 360 degrees Celsius. And after this crude oil is moved to main column of the crude distillation unit. So after heating in this heat exchanger fired heater up to 350 to 360 degree Celsius, this crude is moved. You can see this arrow. This is moved to main column of the that is crude distillation unit or tower or the column. Now we will be discussing about the product of CDU. Now, when these crudes are entered into the crude distillation unit, we will be discussing about what type of products we are getting from this single crude distillation unit or the column. So the lighter product from the CDU, the lighter CDU is nothing but crude distillation unit. So lighter product from CDU is moved to a stabilized column, and lighter product fuel gas is taken or LPG is taken from the upper section. We can see from here the upper section from the here some LPG or the fuel gas or the lighter portion are taken from the upper section. Where from bottom of the stabilized naphtha, uh, if we want to further separate, then it is again taken to the deethanizer from top of the fuel gas to or extracted from the bottom of the LPG. So you can say this Again, these are pumped again, and again it is heated, and then afterward again some amount of lighter fuels are taken. Now stabilized naphtha is further heated at 140 degree Celsius. This again it is heated at 140 degree Celsius. And light naphtha and heavy naphtha is extracted from the top and the bottom. So this is again heated, and the light naphtha, two products are extracted from that. That is light naphtha and heavy naphtha. From the CDU, the top part extract naphtha, and first side, this is the first side row, extracts kerosene. You can see this is the first extract. This is the refractionator unit again. There is the first product is kerosene, or the ATF. ATF, kerosene or ATF is the aviation turbine fuel. The pure part of the kerosene are the ATF aviation fuels. That is extracted from the first side row of the CDU. Now, if this first side now is further heated with boiling point of 140 degrees Celsius to 270 degrees Celsius, then the product is kerosene. You can see here the product is kerosene when it is further heated. Then the product is kerosene with the boiling point of 140 degrees Celsius to 240 degrees Celsius. The product is ATF. I already said that when this kerosene is heated at a temperature of 140 degrees Celsius to 40 to up to 240 degrees Celsius, the product is turned into ATF, aviation turbine fuel, the fine product of the kerosene. Now coming to the second fractionator unit, second side row, or the second fractionator unit of the product, the light gas oil, and the third side row product is heavy gas oil. So from the next side row product of the crude distillation unit is heavy gas oil, or the light gas oil. And from the bottom of the product, this the bottom of the crude distillation unit, the residues are taken. Residues are nothing but that the tar, or the you can say the road oils. That is the residue, and the thickest part of the crude oil, which are taken from the bottom of the crude distillation unit. So this is how CDU works. Now I'll be saying about the product from the CDU. What are the products we are getting from the CDU? The first one is fuel gas. Another is LPG gas. Another is naphtha. The next one is kerosene. Another is aviation turbine fuel, light gas oil, heavy gas oil, and the residue or the reduced crude oil. So fuel gas is the carbon C1 to C2. Mostly C1 and C2 will be there in the fuel gas. In LPG, it will be C3 and C4. Naphtha, it is C5, and it is heated up to 140 degrees, 40 degrees Celsius. From there, we can extract the light naphtha and the heavy naphtha. Now, when this is heated on the temperature of 140 degrees Celsius, 270 degrees Celsius, then the kerosene is extracted from the crude distillation unit. When it is further heated to 140 degrees Celsius to 240 degrees Celsius, then the aviation turbine fuels are extracted. Similarly, for the light gas oil and heavy gas oil, the light gas oil is heated to 240 degrees Celsius, or 270 degrees Celsius to 340 degrees Celsius for light gas oil. And for heavy gas oil, it is heated up to 340 degrees Celsius to 365 degrees Celsius. And residues are of 365 degrees Celsius. Depending on the type of crude oil processed, about 25 to 50 degree are residue. So depending on the type of crude oil, what type of crude oil we are processing, depending on the parameters, the percentage of 25 to 50% are formed as residue, means the bottom product of the crude distillation unit. If it's good quality, it will give a 25% of residue, or else it will give, so it will give average of in the range of 25 to 50% of the residue. So the 25 is a light crude oil, where if you giving gives the residue of 50%, that is heavy crude oil. So in refinery, any unit of hydrocarbon is heated more than 350 degrees or 360 degrees Celsius, then it is cracked and changed into coke. That is called petroleum coke. So when the temperature of this crude distillation unit is heated more than 350 degrees Celsius or 360 degrees Celsius, then it will change into coke. That is petroleum coke, which is said to be a coal. And we cannot. So if suppose if we are getting a 50% of residue, so we cannot just throw like that, right? Like if you're getting a 50% of residue, residue, we cannot throw because we are the company or the economy of the company will get in loss. So, but here we cannot hit as well. So we cannot throw the residue as well, and even you cannot hit the residue as well. So to process RCO, this reduced crude oil residue, we take it into a video, that is vacuum distillation unit. So today we discuss about the CDU, that is crude distillation unit, and we'll stop our session here. And in the next video, I'll be explaining about the vacuum distillation unit and what all the products we are getting from the vacuum distillation unit. So if you like my video, subscribe it, like it, and share it with your friends. Thank you for today.